Hi everyone. So, today we are going to start the second chapter. Before going for the chapter, I'll give the two questions for you. So one is, suppose if I add 2 plus 2 what, and if I multiply 2 into 2. So here the answer is 4. Here the answer is 4. But way of reading is different. Suppose here we will say 2 is added to 2, then the result is 4. Here 2 is multiplied by the 2, means then the result is 4. Okay. So, but both are the different. Both are different. We are going to learn about this. The multiplication. So square means a number is multiplied itself, then the product is called as square of that number. Okay, what the definition is? A number is multiplied by itself, then the product is called the square of the given number. Suppose if I take example 4, a number and multiplied by itself 4. So this is 16. So means we can write this 4 square. See, 4 into 4 we can represent in 4 square. So here the 16 is a product, so that's why it become a square. Whose square? That's a 4 square. Got an idea? So a number is multiplied by itself, then the product is called square of the given number. This is the square of the given number. Okay, we'll go for the basic concept before going for the topic. So everybody must and should know up to the 20 numbers means square of the first 20 numbers. So in that, and second topic is also the cube and cube roots. Here the square and square roots also needed. Okay, for that we do. So everybody take down this definition. Once everybody observe here, I am writing from the 1 onwards. So I am dividing this board into the 2 parts. Okay, one is 1 square, means that is 1 into 1. It leads answer is 1. 2 square, so 2 into 2, so that's a 4. 3 square, that's a 3 into 3, it's a 9. 4 square is a 4 into 4, it's a 16. 5 square is a 5 into 5, 25. 6 square, 6 into 6, it's a 36. 7 square, 7 into 7, it's a 49. 8 square, it's a 8 into 8, it's a 64. So 9 square, 9 into 9, it leads to 81. So next one is 10 square. Everybody know that here 10 into 10, that's 100. So 11 square, 11 into 11, 121. 12 square, 12 into 12, 144. 13 square, 13 into 13, it's a 169. 14 square, 14 into 14, it's 196. 15 square, 15 into 15, it's a 225. 16 square, 16 into 16, 256. 17 square, 17 into 17, 289. 18 square, there's a 18 into 18, it's a 324. 19 square, 19 into 19, 369. And 20 square, okay, here the Fermi space is not there. Okay, I am writing little bit small. 20 into 20, it's a 400. 21 square, that's a 441. 22 square, 484. So as like go on. 25 square, 625. So 35 square, as like you can say 1225. You can say up to the hundreds. Okay. So before going to the topic, once everybody observe this all the numbers, how I remembered as like digits, not as like a number. I never read any one as like a number. Just I will remember as like a digit. So that's why I am able to write this one directly. Okay. So if we observe these all numbers, some similarities are there. So that we will identify first. See, here the unit digit is 1. So once again here the came 1. And 4. So next here the 4. 9. Here the 9. 6. Here the 6. 5. See, if you see there, okay, 0 is there. And 1 already came. 4 also already came. 9, 6, 5, 6, 9, 4, 6, 0. Okay. So what are the digits are coming in a square number that are, so I am writing here. See, that is 0, 1, 4, 6, 9. How many digits are these? And 5 also. Okay, we'll write in a serial order. 4, 5, 6, 9. Okay, only these digits are coming. That is 0, 1, 4, 5, 6, 9. Not only for this up to 20, if you write for the lakh also, you will get the unit digit only this one. So you never get so remaining numbers. What are the remaining numbers? See, the remaining numbers are 2, 3, 7, 8. See, 1, 2, 3, 4, 5, 6. And this 4. Total we get 10 digits. Got an idea? So, sometimes they may ask the question, by seeing only you should say the answer. That time you can use this technique. Surely they will give the square number. If the unit digit is the 2, 3, 7, 8, then that digits are not perfect squares. If the unit digit is 0, 1, 4, 5, 6, 9, probably means if they given accurately, so then we can say that it's a perfect square. Got an idea? Can I repeat? Okay. For your case, once you see that only the unit digits, so unit digits that are 0, 1, 4, 5, 6, 9, these digits will come for a perfect square. So there's 2, 3, 7, 8. These digits, if it is there in any number, means if it is there, if they given on some numbers, in that the unit digit is that. So you can say directly that numbers are not a perfect square. Okay. So next one. So everybody take down this. I'll go for the up to 100 by the logic. Okay. Once I will write for the 10, and next I will write for the 5, 15, 25, 35 as like. Okay. Okay, first I will write for the 10. See, 10 square I am writing directly, that is 100. See, 20 square 30 square, 40 square, 50 square, 60 square, 70 square, 80 square, 90 square, 100 square. Okay, for this numbers I am going to write the result. So 20 square, see here that I can write directly as like, see blindly also I can write, just I know the only square numbers, so by using that I am writing for these numbers. So at least I am not giving the time to recapitulate, just by simply I am writing the digits. How I means what technique I used here. Say if we close this 0 digit, then these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, see you here if we close this, see 1, 4, 9, 16, 25, 36, 49, 60, 40, 81 and 100. So that are the square numbers for the first 1 to 10 numbers. Got an idea? Yeah. So next we'll go for the 5. 5 square is 25 here. So okay, 15, 25, 35, 45, 55, 65 square, 75 square, 85 square, 95 square. Okay, you can write for the 105 square also. Whatever the number also, if they given continuation, same technique, by using the same technique you can write it. Here, see, blindly I am going to write, means without doing any calculation. Okay, see 225, see here the 625, here the 1225, next one is 2025, so next one is 3025, so next one is 4225, so next one is 5625, so next one is 7225, so next one is 9025, so next one is 11025. I did not do any calculation, just I used one technique. What is that technique? So in a previous class, in 7th class also I told the same technique. So how many of you remembered, means how many you know this or not? So once I will explain here. See here this digit is 0. Okay, nothing is there. The next number is 1. So 0 into 1, 0. So 5 into 5, 25. See, last digit is always 25. See. Okay, the last two digits are the 2 and 5. So next two digits how I got? See, 1 is there. So 1 into 2, 1, 2 is a 2. So 225. See, 2 into 3, 2, 3 is a 625. See, into 4, that 3, 4 is a 12, 2, 5. Next, 4 into 5. Next, into 6, 5 into 6, 30. Into 7, 6, 7 is a 42. So into 8, 7, 8 is a 56. So into 9. So that is a 7, 9, 9, 8 is a 72. Into 10. So 9 into 10. So 90. So next into 11. So 10 into 11. 110 into 5. I use that technique. Already this one I gave in my another video also. Okay. And now here some points you want to remember. Here how many zeros are there? 2 zeros. See, every time in a square number, in a perfect square number, we will get a even number of the zeros. Even number of the zeros. Suppose 1000, if I take the 1000 is not a perfect square because the 3 zeros are there. Okay? So, but if you check it here, once you check it, here the 2 zeros are there. Here also 2, even. See here the 4 zeros. It's also even. Means in a perfect square, if it is a perfect square, to recognize that this is also one technique. When it comes the zeros as a unique digit. So here, if you see the pattern, as like everywhere you will get a 2, 5 is a last 2 digits. And I use the technique, how I used means what the technique I used I explained here. means that this is a unit digit into the next number. So 3 is there, next number 4. 4 is there, next number is 5. 5 is there, next number is 6. 9 is there, 9 into the next number is 10. So 90. Okay, yeah? Is a square root. Means we can write a, see, before going for the square root, once I give the introduction, here, this symbol is known as a square root. So we can represent as like also. It is empty, means suppose the plus sign means a plus number, positive number. We won't keep the sign before that. If it's a negative number, then only we will keep. Yeah. Here also, if it is an empty root as like, then it's a square root. So no need to mention the 2. It's another is also, we can, this is equals to 1 by 2 also we can say. So suppose, if I write here, suppose 4 is there. 4 square root means I am writing here this 4. So if we go extend here, can I write this 4, 2 to the power 2 and whole to the power 1 by 2. And the exponent of it, 8x to the power m and whole means in a bracket, then the n, then that we can write in the form of that 2 into 1 by 2. So 2 and 2 cancel, then we can get the 2. So we read as like square root of the 4 is a 2. And before one, why we, how we write? Square of the 2 is a 4. Okay? So it is a reverse case, vice versa also. Okay? Got an idea? I'll give the one more example. Suppose root 25. How we write? See, root 25 means in this only 5 square. This root means what? Empty means if I keep only this root, then it means 5 square whole to the power 1 by 2. It means 5 to the power 2 into 1 by 2. So 2 and 2 cancel because it's a numerator and denominator we can cancel. If they're both in the numerator, then I cannot. But one is a fraction, one is a number. So then I can cancel. So now I got here 5. Okay? Here, first now we want to take here the perfect square numbers. For that, we can write the square root. Okay, here I am taking, so for root 1 value is 1 only. So root next 2 is not there and 4. Root 4 is 2. Now I explained now before. So next one is root 9 value is 3. Root 16 value is 4. Root 25 value is 5. Root 36 value is 6. Root 49 value is 7. So root 81 64 value is 8. Root 81 value is 9. So next one is, so root 100 is 10. So root 121 is 11. So root 144 is 12. So root 169 is 13. So root 196 as 14. So root 225 is 15. So root 256 is 16. Next one is root 289 is 70. Root 324 is 18. So root 369 is 90. So root 400 is 20. So root 441 is 21. So root 484 is 22. As well, you can write up to how much means how many answers. That is depend upon you. If you are able to remember, then you can write. Yeah? Got an idea? Here, once again you can check the unit digit. See, 1, 2, 3, 4, 5, 6, 7, 8, 9. They are coming serially. Okay, there you want to remember the logic. Here no need to remember the logic. And as like you can write for the, now I given for the 100 numbers now, as like you can write for the 100. So 10 square means 100 square, 100, root 100 is 10, root 400 is 20, root 900 is 30, root 1600 is 40, root 25. In a square number only. So one more, by using one technique we can write for the decimals also. So once I go for that, so decimal I'll write from the 11 onwards, means 1.1. See, that is 1.1. Okay, whole square. 1.1 whole square equals to 1.21. Here 1.2 whole square equals to, see, 1.44. So 1.3 whole square equals to 1.69. 1.4 whole square equals to 1.96. 1.5 whole square equals to 2.25. 1.6 whole square equals to 2.56. 1.7 whole square equals to 2.89. 1.8 whole square equals to 3.24. So 1.9 whole square equals to, so 3.69. See, 2.0 whole square equals to 4.00. So 2.1 whole square equals to 4.41. As like you can go on up to the wherever else. See, same one I'll apply for the 5 also. Means see, 1.5 already wrote now. So next I'm going for the 2.5 whole square. So 2.5 whole square means 6.25. So whole square equals to 12.25. So suppose 4.5 whole square equals to 20.5. Next 55 whole square equals to 0.65 whole square equals to, means the basic one if you know, then you can write this one is very easy. Okay, so for these numbers also we can write the square root also. So if you write for these numbers, can I write once? So by a little bit modification I am going to write. So this one also you write it in your notes. I am going to write. In case, suppose here I is like, so square root. Square root means this one, so 1.1, this one 1.2, square root. For this square root 1.3, this square root 1.4, for this square root 1.5, this square root 1.6, for this square root 1.7, for this square 1.8, for this square, so 1.9, for this square 2.0, that's 2. So for this square 2.1, for this square 2.5, for this square 3.5, for this square root, so that's 4.5, for this square root, that's so 5.5, for this square root is 6.5. See, here I applied the square root. So square root of 1.21. So immediately it's a quite reverse of the basic one. Before what I wrote for that reverse. So here, so square root of 1.44 is 1.2. Square root of the 1.69 is 1.3. Square root of the 1.96 is 1.4. The square root of the 2.25 is so 1.5. Square root of the 2.56 is 1.6. So square root of the 2.89 Okay, is a 1.7. Square root of the 3.24 is a 1.8. So as like you can write for all. Means once if you learn the basics perfectly, then you can write as like you can modify and you can keep it the 2 decimal points also, 3 also, it's a 0.00 also, whatever also. You can convert very easily. But basics are important. Okay, this is the square root. Finding the square, another method is also there. So in finding the square, another method is there is a plus b whole square and a minus b whole square. See, a plus b whole square, and one more is a minus b whole square. Already I have given this one in both the pictorial form also, and I explained very clearly. I think everybody you observed that videos. If it not, then you can go for my channel and you can check it. So once I go for the stepwise. Here it's a 2 times. 2 times means what? A plus b into a plus b. So I am doing in horizontal method. We can do in the vertical method also. We can represent by pictorial form also. Okay. Once I write for all the methods. See this one number into this total here, and this one into this one here. So here there's a into a plus b into a plus b into this total, a into this total, b into this total. This plus symbol will come here. Now a into a, that's a square. A into b, here the plus symbol will come as it is. A into b is ab. Here this b into a, can I write in ab? Because 2 3s are 6 only, 3 2s are 6 only. In into there is no problem. It's a commutative property. So b into b is b square. So finally we got that a square plus 2ab plus b square. We can use this method. Okay. If you want in a pictorial form, then I'll show here. Suppose up to here I am taking a, up to here the b, up to here the a, and up to here the b. So a into a square, a into b. See here into a into b, ab. So next b into a. Can I write ab? I am writing ab. So next one b into b square. So 4 together. See, like term together we can add. So a square plus ab 2ab plus this is a b square. This is also another method. Okay, this is a horizontal method. This is a pictorial. So one more is this vertical method. Can I show vertical method? No need. Okay. Everybody take on this. I go for the vertical method. See that a plus b, this method. Okay. Now we'll start from the. So how we will do for the numbers now? As like only I am going. So here the b into b plus the b square. B into a is ab. So next. So second digit we are going. See this a into b, ab. This we will keep that as like into mark in general. Same. A into a. See both are the plus. So this side is plus now. So we are keeping plus a into a square. So total together is b square plus 2ab plus a square. As like we can show more than the 10 methods. How you will understand now, as like we can go through. So now I explained in 3 cases. Now for you, homework is this: a minus b whole square. In these 3 methods you apply. Okay? Will you do? Is there any doubt? Here or there? I think some of the members they may have the doubt here. See how I done once I'll check. B into B, here, B into A, it leads here, A into B, it came here, A into A, it came here. So better way, this is pictorial representation is a very easiest one. Here that's a plus and here the plus, that is A plus B whole square equals to A square plus 2AB plus B square. And you everybody must should remember the order. The same A to the power 2, here A to the power 1. Next B to the power 1, the next term is B to the power 2. Means it's coming in an order. Some people they will write as like A square plus B square plus 2AB. That's wrong. So you must and should write in this one. And we are going to do the square numbers by using this method and this method also. Okay. Once I will recapitulate that. For any one method I will explain. Which one? Can I go for the vertical one? Can I go for the pictorial one? Can I go for the general? Take the decision fastly. So A minus B whole square. A minus B whole square. Okay. The textbook where we go. That is 2 times A minus B into A minus B. So first term into the total term A into A minus B. See next term consists of minus. So you want to keep here the minus B. Means that this total term come here into this total next term. So in this braces, what we have the first term into total the braces, the second braces. The second term word sign consists, that sign you must and should keep it here. So then B into that. Here A into A square, and plus into minus is minus. Plus into minus is a minus. This is a AB. Here minus into plus is a minus. B into A, I can write AB. Minus into minus is a plus B square. So this is A square minus 2AB plus B square. I'll go for the pictorial method. It is for your understanding only, not theoretically. For just for your understanding purpose. Suppose I am thinking this total is A. Okay. So from that I am coming back. So this is a B. Means this part is a B up to. Means that this is a A minus B. That part is a A minus B. But I am not going for that much depth. Okay. Just for your understanding purpose I am giving. So here this is a and this is a minus B. Now see here into A square, and this is A into minus B minus AB, minus into this is minus AB, minus into minus plus B square. I will like also, but this is only for your understanding purpose. Okay, in the textbook also they give it, but original proof is different. Okay, I'll explain that one also. In the original proof means those who will go for the theoretical proofs, means in depth. So there we want to use an accurate one. Okay, it's for only understanding purpose. This one is in your textbook they given, and you can do the vertical method also if you want. In this session we learned about the square numbers, square roots, okay, and way of means method of finding the square number in the second way, that is A plus B whole square and A minus B whole square also are given. So more methods also there. Diagonal method is there, column method is there, so many are there, and everybody you practice that means basic one. What I given the basic one now, so 1 to 20 numbers everybody must ensure that remember, means by heart that the square numbers and the square root. If you remember the square numbers, then you can write for the square root very easily. And I given the technique for the 10 square, 20 square, 30 square as like up to 100, and 15, 25, 35, 45, 60, 65, 75 as like also up to 100 I given. Okay, you can apply that one for the next also. If you have the doubt, you can check for the next 5-6 numbers. Okay, everybody must ensure to remember 1 to 20 square numbers. Okay, and homework is this test your concept. So 1 to 10. So which are the very simplest one, means a very small one. And some people immediately they will do call and sir, what is the answer for this? So before asking me, once you go for the textbook and you read all the points, from that only you will get. Okay, if you learn yourself, then it will be permanent. I can give the answers as like very directly. If I give the answers directly, then it won't be permanent for you, because if you find your answer in your way, okay, then it will be permanent. Suppose if I don't, I can give very easily, but you will forget afterwards. So when I give the homework now, that time immediately some people they will call and they will ask, sir, what is the answer for this? What is the answer for this? No, first you should try. Everything I will give from the textbook only. I won't go beyond the textbook. Okay. Now I am giving only from textbook. I am giving. If you want means I will give the next. Okay. Thank you, my dear children, and complete the notes as soon as I'll check your notes after this session. Okay. Bye bye.